Yeah, I kind of wanted to talk to you guys about supersymmetry.
We've got 3 minutes.
You got 3 minutes?
Supersymmetry in 3
Final
minutes.
is next Tuesday, is that right? I think so.
Oh my goodness.
And
Okay. I have to write a final for next Tuesday for here.
well, you have to write half of the final.
Half of a
Don't
final.
write a final document. Write a quarter of a final.
Just,
Yeah, we'll just do like.
just write a quarter of a final.
Write a quarter of a final, because then you'll give us half a final. And then
That's funny.
And you can get at most 75 points on it.
Come on.
29 a.m.
Dang it.
Some of these are kind of early in the morning back here, or late at night.
Yeah.
How big is your hard drive?
I don't know. Ah, there it is.
Oh, this thing, yeah. I know this thing. I don't know about this thing.
See ya.
See ya.
So, so like in my thesis, I look at superspace, and that's kind of like a similar discussion about these things, in the sense that like there you can look at, it's more of the same stuff we're doing. Let me show you. So like we got momentum. Momentum and angular momentum, and these are its commutation relations. And the interesting thing is there was a no-go theorem by Cullum and Mandula that basically said that the Poincare group, which is the group of like special relativity, space-time translations and boosts, rotations, all that, it they said let's see here. That any additional operators must obey commutator brackets. Oh no, I'm not saying this right. Yowzers. Well, anyway, I just wanted to show you really just like one equation here. I'll find it eventually. So here's your homework problem, basically. So
Superscript?
this is the what is this? What is the D? Man, it's been a while. Well, anyway, the momentum is represented by minus I partial xm.
You said it above the linear differential operator.
Oh, okay. So, but I've set h bar equal to 1 here apparently. And anyway, so long story short, here is the representation of the Poincare algebra in terms of differential operators. So like momentum, these are angular momentum, these are the boosts. So the Poincare algebra is 10-dimensional. 10-dimensional. It's like the, I think, semi-direct product of space-time translations and the Lorentz group. But the interesting thing is, it turns out that that can be extended by adding what are called supercharges. And supercharges, which I use Q as the typical thing here, and the supercharges, come on, man, satisfy some, come on, I'm looking for a particular equation, I can't find it. Oh man, where's that stupid thing? Well, anyway, what I was trying to show you, and I can't find it. Oh, there it is finally. It's hidden in the paragraph. So this is an anti-commutator, which is, instead of doing a minus in the middle, you do a plus. The anti-commutator of Q alpha and Q beta bar, it's actually twice this is the Pauli matrix and the momentum. So in this sense, the supercharge is kind of a square root of momentum, people will say. And what these calculations show is that superspace allows you to represent the supercharge by just a derivative with respect to supercoordinates, in the same way that you can represent momentum as a derivative with respect to ordinary coordinates. So this superspace, which has 4 commuting and 4 anti-commuting coordinates, it's the natural place to represent supersymmetry, which is like an extension of the Poincare algebra by a couple of, well, they're called supersymmetry generators because the symmetry that they're generating is a supersymmetry. Supersymmetry is interesting because it does all kinds of crazy things, like links things that are fermionic with things that are bosonic, which is sort of shocking and not before seen in physics. And at the moment, it's still, I think, a theoretical conjecture. But people kind of think there's something right about it, because when you inject supersymmetry into like your theoretical models, you're able to do calculations that you just can't otherwise, which means there's something beautiful about it, which probably means there's something real about it. But no one's really sure at the moment, I think. So anyway, that's as good a place as any to stop. So this will not be on the test.